Let us now look at how do we read parameters from file so that we can access some data from a file which has been written by our solver. So I have created this small example file. So this is the file which I have created, which stores some parameters like stop time, CFL, X cell values, the number of X cells, the number of Y cells, number of ghost cells, order of accuracy, the number of time steps used for RK time stepping, and so on. You can add more parameters depending on the kind of problems you are solving and the kind of data which may be required for plotting. So we have these variables, and the first task is to read this variables or parameters into appropriate data types in our plotting code. We will later on look as to how we can read the actual data, but as of now let's start by reading these parameters. So reading parameters can be divided into two parts. One is to actually read the parameters from the file and put it in an appropriate data type, and the second part would be to parse the read data into the desired data type so that it can be used later on. Okay, so the first part is to read the parameters. So let us define some parameter for saving the file name. So let us say file name is equal to solution.dat. That's the same file name here that I have created. Remember, it has to exactly match the file name. So if I say use a small s, then it will not work. It will not be able to read that file. The way in which we open the file is by using the open function. So let us create a file object and open the file by using the open function. So this is the file object that we have created. Now to read each of these lines from the file, we can simply use the for loop, and we can say line in file object. So this will read each of the line from the file object and assigning the string associated with each of the line one at a time. This line will reference to one line at a time from this file. So let us just see what happens. Let us print the line and check what happens. So the output will be put here. So let me run this, and you can see that all the lines have been read, and you have this additional lines, new line characters, which are because there is a new line character at the end of each of these lines. So you first of all want to remove any additional things which might be there, like for example there might be some additional spaces here or some tabs or something like that. You may want to remove those extra things. Also you will need to remove this extra new line characters which are there at the end of each of these lines. So to do that, let us use the strip command, the strip function. So this function removes any additional spaces, so it returns a copy of the string with leading and trailing white spaces removed. If the character is given or not or none, remove characters in the chars instead. So you can actually pass some character if you want to remove some additional characters. Anyways, so this will remove the trailing and leading white spaces, and it will also remove the new line characters which are there at the end of each of the lines. Now if I print this line, you see that these new line characters have been removed. Also I had put some space, let me put this space here. Also you will see that there is no space at the end of this particular line. It has been removed. Okay, so this has been done. Now what I would like to do is, I would like to read the parameters which has got this particular format, that is a name followed by a equal to sign and followed by a value. So it can be any value actually. I'll also maybe use later on a string to demonstrate. So this particular format. So let us do this. It's very easy to do. You can simply use let us say, what name should I give here? Let me define a value. So let me say key value pair. So it's equal to, so this is just a variable name that I have defined. So I can use line dot, and I can use the split command. So I can split the string by using equal to. So now what will happen is, the lines which have got an equal to have been split into two. So here there is no equal to, so it's a single list which has been created. Here there was a equal to, so a list of size 2 has been created, with the first element being the stop time here and the second element being 10, and so on. So I am only interested in the values or the list which are of length 2. So let us now say, if the length of key value is equal to 2, only then I will do the print. So let us see what happens. Now only those values have been extracted which are having this particular format, otherwise nothing has been done. Now I would like to put these values in a dictionary. So let us define an empty dictionary first. Let me call it params or for parameters, and let me define the key for this parameter. So the key is going to be the first element of the list. So it's going to be the first element of the list, and the value is going to be the second element from that list. So this key of dictionary parameters is going to be associated with this value. Okay, now let us try printing the full dictionary. Okay, and you can see that all the elements, that is all the required parameters, have been read into a dictionary. Now the next part is to define appropriate value types for these parameters. That is, for example, here this is a floating point number, but it has been taken as a string. This is an integer, but it has been taken as a string, and so on. Well, there is one more problem here. Also, there are these extra spaces. They have come because of this. So let us also remove these extra spaces. To do that, you can easily do it. Again, let us use the strip method here, and you will see that those additional spaces have gone away. Let me print it. So you will see that those additional spaces have gone away. Now the strings are well formatted, but the problem is that these are strings and not the values of desired type. So let us now convert them one by one into desired value type. So to do that, you first of all define a variable. So let us say we want to save the CFL, or let us start with stopping time. So in fact I can just do this. Okay, now the stop time is going to be the value associated with the key stop. Let me just do this. Okay, the value associated with stop time, but now I want to cast it into a float. So let me do that as well. And now this stop time is going to be the value which is associated with the key of parameters but converted into a type float. Let us do the same thing for the remaining ones as well. Okay, this is going to be CFL, this is going to be X, this is going to be Y, this is going to be number of ghost cells, order of accuracy, RK steps. I hope you are understanding what I am doing here. I am just taking the key associated with that particular value and I am converting it into the type. Here also X cells has to be converted into int, so let me convert it into int. Y cells is going to be an integer, number of ghost cells is going to be an integer, order of accuracy is going to be an integer. These are just, I've just chosen some arbitrary parameters. I may not even be using all these parameters for plotting, just to show what is going to happen. Okay, now once we have converted it into the appropriate types, now we can print this out. So actually we can do even better. We need not even create this. We need not even create these separate types. What we can do is we can just change the appropriate key from the parameters. So let me do this. Okay, I hope you have realized what I have done here. So what I have done is I have changed the value associated with this key into the appropriate type. Here in this case I have changed it to float. Here I have taken the same value but I have converted it into float. Here I have taken the same value but converted it into an integer, and so on. So let me now try printing the parameters, and you will see that instead of it being a string, it will be of appropriate type. So if you look at it here, the order of accuracy has been converted into an integer. You don't see those additional quotes. So these types have been changed to the appropriate types. CFL number is a floating point type, and so on and so forth. Let us do one more thing. Let us use a string here. Let us say problem name. Let us say some problem name, say advection problem. Also let us put one more, say author. So author. Okay, and now if you run this, you will see that things have been changed, and these names are not changed. Oh yeah, I need not put this additional quotes, right? I need not put these quotes. Okay, now if you see, these keys are associated with appropriate strings in this case. You may also want to explicitly convert it into a string even though it is a string, so I'll show you why. So you may want to do something like this. So let me copy, paste, and let me convert it into a string. Oh, actually I can use this. Okay, and the same thing with the problem name as well. Okay, and paste. So I have converted this into string type. Well, nothing has changed in this case, but the reason why you would want to convert it into an appropriate type is to just catch any error which might be happening. So for example, the CFL number might be written by a solver as something, say I don't know, let us say something which is not convertible into a float. So in such a case, we want our code to throw an error that we are unable to convert it into a float. So for that reason, it's important to typecast everything that you read from the file. So now we have read all the parameters and we are ready to now use these parameters and do our plotting. So main parameters, most of the variables which are important for us actually for plotting will be things like, say, stopping time. So we may want to have a title of our plot as the stopping time itself, so that it is not confused. I mean, multiple plots are not confused to be at the same time. Other things which might be important is X cells and Y cells. This will be important to reshape our matrices which we read into appropriate dimensions. Number of ghost cells may be important to eliminate the unwanted cells. Other things I have just added just for the purpose of demonstration only. Okay, so the remaining parameters, the remaining lines which are existing here may not be useful for us as of now, and later on we will read them and use them for additional purposes. Finally, there is one additional thing that we may want to do, is we may want to ignore the lines which start with this hash. That may be important because if there is a equal to here, then it will also read this line. I'll show you what will happen. So it has actually read this line, which may not be intentional, but since it's a comment, we would like to ignore this line. So to do that, what you can do is you can simply add one additional line here saying that if the line starts with a hash symbol, then if the line does not start with, then only you do this, then only it should execute these vertical lines. So first of all, we strip it out of any additional spaces which are there. If after doing that, we will check whether there is a hash at the beginning. If there is no hash, only then these lines will be executed. So let us try running it now, and now you can see that it has not read this first line, it has just ignored it. Even if it has got a equal to, it will still ignore it. So I'll run this. You can see that it has ignored this line. Okay, so that's all I would like to do in this video, and see you next time.